Now, let's look at a problem which is less straightforward than these two. Okay, these two I consider them simple calculation, but this one is more comprehensive. Okay, you place a 5 kilogram object on a horizontal frictionless surface and attach it to a spring with spring constant 1000. The object is displaced from equilibrium of 50 centimeters horizontally and given it an initial velocity of 10 meters per second towards the equilibrium position. Okay. We want to find the motion's amplitude and the motion's frequency. So first, basically says I'm trying to make some oscillation. And how did I start the oscillation at the initial point? So my initial point is somewhere like if this is the equilibrium position. Okay. I pull it away from the equilibrium position, and the distance here is, what's that? 50 centimeters, so it's 0.5 meters. Okay, you need to write everything in standard units. And I also give it some initial velocity at that point. V0 equals to 10 meters per second. And I want to find the motion's amplitude, A, and the motion's frequency, F. Okay, let's look at how can we find the amplitude of the motion. So the amplitude of the motion is at 0.5 meter. Okay? Should it be larger or smaller than 0.5?
Small.
Larger. Should be larger than the 0.5. Amplitude means the maximum possible displacement from the equilibrium. So, see, if I just pull it for 0.5 meter and let it stay there, it will be the amplitude. But I'm not let it stay there. I still give it some energy here, velocity. So that means it can still go further. So it probably can reach some place here. This is the amplitude. Okay. When it stops there. So to calculate amplitude here, we need to use the energy consideration. Okay. Amplitude is usually related to the mechanical energy of the system. So we need to think about the energy conservation. So if you think about the energy conservation for the system, mechanical energy conservation, so you can determine the mechanical energy at this point, right? You know the velocity at this point, so you can calculate the kinetic energy. You know the distance, the pulling distance here. So you can calculate the spring potential energy. If you add them two, you get the mechanical energy. So you can calculate the mechanical energy first. You can calculate E equals to 1/2 kx squared plus 1/2 mv naught squared. So do we know the mass? Yes. M equals to 5 kilograms. And do we know the spring constant K?
Yes.
Yes, 1000. So we can calculate the mechanical energy. Okay? On the other hand, the amplitude is related to the mechanical energy. Right? What's the relationship between the amplitude and the mechanical energy of the oscillation?
E equals 1/2 kx.
E equals to 1/2 k AM squared. Right? So if you equal the 2, so here I write down the equation by calculating the mechanical energy here and relate it to the mechanical amplitude by looking at the definition of the mechanical energy for the oscillation. Okay. So on the other hand, this equation can also be understood from the point of view of mechanical energy conservation directly. This, if you consider this is our initial stage, this is our final stage. So this is the initial mechanical energy. This is the final mechanical energy, where you don't have kinetic energy because the velocity end here is 0, right? Question?
I was just wondering if it makes a difference, because it says the initial velocity is towards the equilibrium position. So does that make a difference?
Towards the equilibrium, it doesn't make difference. Okay, so at this point, the equilibrium to this velocity to this direction or to this direction, it doesn't make the difference for the energy because this is v squared. Okay. Question?
So the maximum like compression equilibrium equals the maximum like can you call it equilibrium with the distance equal?
So yes, so this quantity when we talk about the amplitude, the same as the maximum we are talking about before for the oscillation, the maximum stretching process, stretching distance or maximum compressing distance. Okay, which is the amplitude. Amplitude has a meaning of where the object stops. How far is made away from the equilibrium. Okay. Any other question? Okay, so of course you can do the calculation, okay, to find the amplitude, okay, in meter. Okay. Now let's look at part B. Part B, you want to calculate frequency. Okay, so what do you want to calculate first? Frequency. Which one is relative frequency? Omega. Okay, our important first guy, omega. So you need to first calculate omega and then you can calculate frequency. Okay. I heard K. K is related to wavelength, not frequency. Okay. So omega. And how can we calculate omega here? In those problem, that's not a problem. You have the equation. So what number be in front of the time t, that's the angular frequency omega. But here we don't have the equation of the oscillation. How can we find omega?
The square root of k over m k over r.
Okay, yes. So there is the fourth law for the oscillation of the spring system, which says that omega equals to square root of k over m. Is it correct? K over m or m over k?
M over K.
M over k. Or k over m?
No, it's M over K.
Okay,
No,
so
it is K over M. Yeah, I'm sorry.
let's go.
I'm looking at the one for period.
Okay. So this is correct, right?
Yes.
So if this is correct, then that means, okay, you know k, you know m, right? You can calculate square root of 1000 over 5. So you are going to get some number. And then frequency is simply 2 pi f in hertz. Okay? Any question here? So part A is about the energy aspect of the oscillation. Part B, you need to consider the force law of the oscillation in calculation. But again here, omega is very important. For most of the quantity, you want to find out them, you need to find out omega first. The only quantity which is not is independent with omega is the amplitude here. Amplitude is independent with omega. Okay. So I would like to stop here. So if you have questions, you can ask me. And so to prepare for the exam, you need you need to do all the homeworks and the problem on the slides, all of them. Okay, I will have both the problem from the homework and the slide.